For science today, we're going on to, it's kind of like a little bit of a segue, like a bridge between what we did last week on the 4 different properties of air, and then what we're doing this week, which is kind of getting into a little bit more flight stuff. So there is a new I can statement, which I would like you to write down. I suggest you probably go to a new page because, yeah, it's probably just going to be easier. Probably don't have enough room on your other one. Okay, so here we go. All right, the title is Air Can Be Compressed. So this is, this is also a property of air. So I can provide evidence that air is a fluid and that it is capable of being compressed. Identify examples of these properties in everyday applications. Okay, so that's what we are doing today. All right, so, okay, this is a lot of information on here. Okay. But this, again, you do not need to write all of this down. I would suggest you just do like a little sketch though. So what state of matter is air? Hopefully we can understand this. Obviously, it's not a liquid, it's not a solid, it is a gas, right? But fluids, a fluid would also be a correct answer because liquids and gases are both fluids, right? They have the same properties. That means that they can like flow. Okay, so this should be totally reviewed from grade 5. You guys did this, I believe, in grade 5. So just a summary, you do not have to write all of this down, but basically I'm just going to say it quickly. So a gas is when there are molecules that are separated by large spaces. So it fills up a container and it has a definite volume, but it can be compressed, which we're going to talk about today. Molecules are moving freely and gases flow. Molecules have high levels of energy. Okay, yeah. So basically they're just like going like crazy and the molecules can spread out and they take up the whole entire space of whatever container that they're in. A liquid, in comparison, has molecules are closely spaced. So that means they're closer together than a gas. They take up the shape of the container that has a definite volume. So say, for example, like the container is like the size of this little column, then the liquid would take up whatever space is in the bottom, like however full it is. The molecules can move past each other and the liquids flow. Yeah, so that kind of makes sense. And then molecules have in-between energy levels. So it's kind of like medium energy levels of a liquid. Also, you should have learned this also like last year, depends upon the temperature, right? If the liquid has higher temperature, then the molecules are moving faster. And then if the temperature is a little bit cooler, then the molecules don't have as much energy, so that means they're moving slower. Okay, then the last state of matter is a solid. So solid, the molecules are fixed in positions and they only collide with their direct neighbor. So again, it's like a block, right? Any object that you have would be, the molecules are packed, they're not going to move. It has a definite shape and volume. So say we had like a little piece of gum or something like that, right? It's not going to change, I guess, unless it melts, but it's not really going to change shape. The molecules have low levels of energy and they only vibrate a little bit to stay in place. Okay, so this is like a little bit more information that you need to know, but I'm still just going to say it. So the particles of gases are made up of air that have a lot of kinetic energy. So kinetic energy, you're going to learn more about this when you get to junior high, but kinetic energy is basically energy in motion. And then potential energy is energy that's stored. So it could move. There's the potential for the energy to move, such as this balloon. So in this balloon, there's potential energy because there's molecules inside. They might be compressed. So it might be like helium or even just like a compressed gas, like a compressed air. But they're not going to move, but they have potential to move. So in this one here, if we were to open the base or even poke a hole, whatever, in the balloon, then the balloon would rocket off and it has something that we call kinetic energy, which means that it's the movement of something. Okay? A little kind of preview into grade 7. You don't really necessarily need to know that though. Okay, the moving particles collide with enough force to create large spaces between the particles. That's right. So when there is a gas and when there's a kinetic energy, the more kinetic energy there is, the more the particles are moving. And then when the particles kind of stop moving, with the same amount of force, with as much force as they had originally, then we're not going to notice any more motion, right? So like when the air that would have been condensed or pressed into this balloon is released, then eventually it's going to stop moving once the air has all kind of like equalized. Yeah, okay, hopefully that kind of makes like a little bit of general sense anyway. But basically we just want to say that like when the molecules can have different amounts of energy depending upon how tightly and closely they're packed. Okay, and then I suggest that you draw a little picture of each state. So you can do that if you want to. Okay, now the next thing is, okay, so how can air be compressed? Okay, now this is kind of a really cool thing to think about. So because of the free flowing spaces like this we see here between the air particles, it means that the air particles can actually be jammed in together and made to be closer together, or squeezed or compressed. And the root word of compressed is press, right? You're pressing them closer together. So the extra air can be squeezed into a container, which means that the air pressure inside of a container could be greater than the air pressure outside. Okay, so that's kind of the same thing with like the balloon. I'm just gonna go back there. So extra air can be squeezed into a container or into a balloon or into what else? Maybe like a car tire or a bike tire, right? Which means that the air pressure inside the container or inside the balloon or inside the tire is greater than it would be outside. So here, this is an example, right? We could shove more air molecules, like you take a whole ton of breaths, you can shove all the air into there. And then if you instantly release it, then the air's like, oh, we want to have more space. And then the particles go back to how they were originally. Okay. So what I'd like you to do definitely is draw a picture of compressed air in a container, okay, versus air that is not compressed. So say, for example, this is the air that's not compressed. What would the air look like maybe in a balloon? Or you could draw the same size square with air that is compressed. Okay, so what would you see as a difference in the little air molecules? What would you notice about the spaces between them? Okay, all right, so we're just gonna watch a quick little video. Same thing, this might also help you with the picture that you're going to draw.
Here's how compressed air can launch a t-shirt. When air molecules are pushed into a cylinder, they collide. Adding more air molecules in the cylinder means they have less space to move, so they collide more often, building pressure in pounds per square inch, or PSI. When this compressed air is released into a second cylinder with lower air pressure, the difference in pressure creates a force that shoots the t-shirt into the air.
Ta-da! Okay, so that really...
The difference in pressure creates a force that shoots the t-shirt into the air.
Okay, we can watch this again.
Here's how compressed air can launch a t-shirt. When air molecules are pushed into a cylinder, they collide. Adding more air molecules in the cylinder means they have less space to move, so they collide more often, building pressure in pounds per square inch, or PSI. When this compressed air is released into a second cylinder with lower air pressure,
Okay, right. So we see the air pressure here is very different. Here would be super high pressure of the air molecules. And then this would be low pressure. So there's like nothing really going on out here. And that shows that this air is compressed and the air doesn't like being compressed. It wants to get back to its original state. So...
in pressure creates a force that shoots the t-shirt.
Yeah, it shoots the t-shirt. So it's going to kind of like reach a certain point. That's the exact same way with how your like water guns and your air guns work. It's the same thing. Air is being jammed inside here until the pressure in here, this solid can't take it anymore and it has to find a way out. So that's all you really have to do today is just draw a picture of compressed air in a container. So even something kind of just like this, but I guess showing like a little bit of particles out here. Yeah. Okay, so that was kind of easy, I hope. Okay. Okay, and then the last thing is just this. Can you think of examples of items that have compressed air? Try to think of at least 3. Okay, at least 3 things that have compressed air. That shouldn't be too hard for you to do. You should be able to think of, I'd say even more than 3. But yeah, try to think of 3. And then we could also kind of think about like, what happens when the compressed air is no longer. So for example, in that water gun or that air gun or like the t-shirt gun, then like what do you notice? Like what can you observe that's happening? Okay, so that's it. That's all you need to do for science today. Just that. So drawing down, I guess you might have needed to do a little bit more work on this, like doing a little sketch of each of these different states. And then like a little something about like what kinetic energy is. Okay, so kinetic energy basically is energy in motion. Potential energy is stored energy, so it's not moving yet. And then the main thing is drawing a picture of compressed air inside a container. And then, draw a picture of an air inside a container that is compressed versus not compressed. Okay, and that's it for science today. Tomorrow I'm going to show you guys kind of a cool video tomorrow. And then that's going to get us into, actually, you know what? No, I'm just going to post a cool video for you to watch after this. It's a little bit long though, and it is a really cool experiment that relates a little bit more to air pressure. And it's kind of interesting. So I suggest that you watch it. If we were in class, I've done this experiment in the past, and if you ask your parents, maybe you could do this at home too, but it's like not the safe, well, you can see your parents would have to for sure directly supervise you doing this experiment. Okay, I'll post it so you guys can watch it after this, just as kind of like an interesting thing to think more about air pressure. Okay, that's it. See you at 2:00 for our optional Zoom, because we're going to do all of our presentations tomorrow. I don't want this like half today, half tomorrow. So come today at 2:00 to do a bit of a practice with your group as like a dress rehearsal. And then tomorrow, full on all the presentations, and then something else the next day. Okay, good job. See you soon.